Hello learners, welcome to Dr. D.Y. Patil Vidyapeeth's Center for Online Learning. I am Professor Dattatray Katore and you are studying with me statistics and quantitative techniques. So far we have discussed univariate analysis, that is the analysis was based upon only one variable. We have discussed measures of central tendency and measures of dispersion. In measures of central tendency we have seen mean, median and mode. These are the measures of central tendency, and the measures of dispersions we studied are standard deviation, mean deviation, range, quartile deviation, coefficient of variation, etc. So all these measures were based upon only one variable at a time, and that's why it is called as univariate analysis. In past two units we discussed bivariate analysis, that is the analysis of two variables at a time. So in correlation we tried to study the relationship between the two variables, the degree of relationship between the two variables, and in regression we understood the cause and effect relationship between two or more variables. So in this unit also, in this particular video, we are going to discuss association of attribute. Now this is again a bivariate analysis, and in this particular unit we are going to deal with the qualitative variables. So in previous units we dealt with quantitative variables, but in this particular unit, that is association of attribute, we are going to deal with categorical variables such as beauty, then strength, then talent, knowledge. So these are all categorical variables. So these are abstract qualities, and that's why they are difficult to quantify. But in most of the social sciences we come across such kind of data, and that's why we have such a special technique here, which is known as association of attribute, which is very essential to study. So in this unit we are going to discuss association of attribute, which is unit 6 of your course, statistics and quantitative techniques. Now what is association? So in statistics, association tells us whether the variables under the study are related or not. That is what association is. So in correlation analysis as well as in simple and multiple regression, we tried to study the association between the variables. So we tried to understand whether there was any relationship between the given variables or not. But the variables we studied in correlation and simple and multiple regression were the quantitative variables. Now we are going to deal with the qualitative variables. Attribute. An attribute refers to the quality of the characteristic. So attribute is any quality of the characteristic, such as beauty. So we are going to discuss association of attributes. Introduction to association of attributes. Statistics does not always deal with the quantitative data. So as already discussed, statistics doesn't always deal with the qualitative data. Sometimes it has to take into account the categorical or qualitative data or abstract qualities also. So often in behavioral sciences, social sciences, where human actions are studied, human behavior is studied, one often deals with the variable which is not quantitatively measurable. So literally an attribute means a quality on characteristics which are not related to quantitative measurement. Examples of attributes are health, honesty, blindness, beauty, knowledge, etc. So they cannot be measured directly. So these are abstract qualities: health, beauty, blindness, then maturity level we can say, perception we can say, attitude we can say, consumer satisfaction we can say. So these are some consumer utility we can say. So these are some abstract qualities or some attributes. These are not measurable quantitatively. So the observer may find the presence or absence of these attributes. So what we can understand whether the attribute is present or not. So statistics of attributes based on descriptive character. There are various notations in this particular unit. So association of attribute is studied by the presence or absence of attribute. If only one attribute is studied, the population is divided into two classes according to its presence or absence, and such a classification is called as dichotomy, because we only study the only one attribute and whether it is present or not, and that's why it is dichotomy. And if the class is divided into more than two scale classes, such a classification is called as manifold classification. Classification of attributes. So there are certain representations that are made in the theory of attributes. The population in the theory of attributes is divided into two classes, namely negative class and positive class. So negative class and these are the positive class. These are the two two parameters based upon which we classify the attributes. Right. So the positive class is represented by the capital letters A, B, C, etc., and the negative class is represented by alpha, beta, gamma, these kind of Greek letters. So positive class, which denotes the presence of an attribute and is generally denoted by the Roman letters, that is the capital letters we study, A, B, C, etc. The negative class denoting the absence of attribute, and it is denoted by the Greek letters alpha, beta, gamma, etc. So for example, A represent, capital A represents the attribute literacy, then alpha will represent illiteracy, and if the capital letter B, that is Roman capital letter B, represents criminal, then beta will represent not criminal. So these capital letters, Roman capital letters, represent presence of the attribute, and alpha, beta, gamma, these Greek letters present or represent absence of the corresponding attributes. Classes and class frequencies. Different attributes, their subgroups and combinations are called as classes. Different attributes, their subgroups and combinations are called as different classes, and the observations which fall in these particular classes are called as class frequencies. So subgroups and combination of these subgroups are called as classes, and the number of observations which fall in these classes are called as class frequencies. If two attributes are studied, the number of classes will be 9. See, we have a table on the right hand side. So in this particular table there are only two attributes, attribute A and attribute B. So let me take the pointer to elaborate. Yes, so here it is, attribute A. So this denotes the presence of the attribute A, and this is alpha, which is nothing but the absence of attribute A. This B denotes the presence of attribute B, and this is beta actually. So the beta represent the absence of attribute B. So there are only two attributes, attribute A and attribute B. A represent the presence of attribute A, alpha represent absence of attribute A, B represents the presence of attribute B, and beta represents the absence of attribute B. So when we have two attributes, then we will be having 9 classes. So look at these classes. AB is one of the class, then alpha B is second, then A beta, then we have alpha beta. So addition of these AB and alpha B will give us B, then A beta and alpha beta when added gives us beta, so on. So this is how we get 9 classes. Look at this narrower table in this particular table. So smaller table of 3 by 3 in the entire table, right? So these are the class frequencies, we can call them AB, alpha B, B, then A beta, alpha beta, beta, A, alpha, and N. These are the class frequencies, and in this particular table we have 9 classes. The number of observations or units belonging to class is known as its class frequency. So this is the class frequency. So when we call it AB, it means that there is presence of attribute A as well as attribute B. So both the attributes are present in this particular class AB, right? So in this particular class, both the attribute A as well as B both are present. So in the class frequency or in the class alpha B, so in this particular class there will be characteristics in which uh, attribute A is absent but attribute B is present, like this. So like this we can interpret this particular table. The number of observations or units belonging to the class is known as class frequencies, and class frequencies are written within the bracket. Thus in bracket capital A represent the frequency of A. In bracket capital AB stands for the number of objects possessing the attribute A as well as B. The contingency table of order 2 by 2 for the two attribute AB can be displayed as given below. So we have this particular table. So classes and class frequencies. The frequency of lower order class can always be expressed in terms of the higher order class frequencies. For example, when we add these two things graphically, let me take the pointer option. Yes, so when we add these two things mathematically, we will get B. So here it is, B is equal to AB plus alpha B. Similarly, when we add these two classes vertically, then we will be getting A. So AB plus A beta is equal to A. Here it is, right? So these are the totals. These are the totals of rows and columns. This is the total of entire rows and columns. So the frequency of lower order class can always be expressed in terms of the higher order class frequencies. So if the number of attributes is n, then there will be 3n classes, and we have 2n cell frequencies. So this is a 2 by 2 matrix, 2 by 2 matrix. So if the number of attributes are 2, then it will be a 2 by 2 matrix inside. So this particular matrix I am talking about. So this is a 2 by 2 matrix. So if number of classes are 3, then it will be a 3 by 2 matrix, that is, yes, 3 by 2 matrix, like this. Consistency of data. Now this is the basic condition which must be satisfied before we proceed with the calculation of based upon this particular table. So in order to find out whether the given data are consistent or not, what we do, we have to apply a very simple test. The test is to find out whether any or more of the ultimate class frequencies is negative or not. So what test we have to conduct? We have to conduct a test by putting all the values in this particular table and finding out whether there is any negative value or not. So if none of the class frequency is negative, so if there is no negative value in the class frequencies in the bracket, then we can simply calculate the given data, and we can say that the data are consistent. The frequencies do not conflict with each other if all these values are positive. On the other hand, if any of the ultimate class frequency comes to be negative, the given data are said to be inconsistent, and we cannot do further calculations based upon this particular data. So it is very essential for a data to be consistent. So all the class frequencies, so all the values mentioned inside the bracket must be positive, then only it satisfies the criteria of consistency. Otherwise data are called to be inconsistent. So we have an example to check the consistency. We have example 1, given n is equal to 2500. So this is 2500. Then A is equal to 420, AB is equal to 85, B is equal to 670. So we'll complete this particular table. Yes. So let me take the pointer option. So let us put these values in this particular table. This n is equal to 2500. Then A is given as 420, so this will be 420, 420. Then AB, capital AB, 85, so where it is, 85 is here. Then we have B is equal to 670, where is B? B is here, and it is equal to 670. So from these values we can complete this particular table. So 420 minus 85 will give us some value. and 670 minus 85, so 85 twos are 170 I guess, so 670 minus 85 will be 585, so this value is 585, right? So this value is 585. Similarly, if this value is 2500 and this value is 420, so we can get this value. So 2500 minus 420 will be 2080, right? So this is also positive value. 420 minus let us calculate this. 420 minus 100 is 320. 320 plus 15 is 335. So 335, this particular value. Then if this is 670, then this value must be 2500 minus 670. So 2500 minus 600 is 900. Okay, 1900. 2500 minus 600 is 1900. 1900 minus 70 is 1830. So this value is 1830. So similarly, we can calculate this value also. 2080 minus 585. So 2000 minus 585 is 1415. 1415 plus 80 is 1495. So 1495 plus 335 will give us 1830. So all the values are calculated and all the class frequencies found to be positive, and therefore we can say that this particular data are consistent, and therefore it is useful for further mathematical calculations. So we have one more example to calculate the consistency of the data. So example 2, test the consistency of the data with the symbols having usual meaning. So n is equal to 1000. So let me take the pointer once again. Yes, it is 1000. I am writing it here 1000. N is equal to 1000. So this is quite simple. A is given as 600, so I am writing A here 600, and capital AB, that is presence of both the variables. So okay, N is 1000, capital A is 600, B is 500, so let us write B 500 here, and capital AB means presence of both the attributes A and B. This is equal to 50. Yes. So as this is 600, the entire frequency is 1000, total number of observations we can say. So 1000 minus 600, this is 400, as these two values must add to n. So 600 plus 400 must be equal to 1000, like that. So as this value is 500, this must also be equal to 500, that's why this is equal to 1000. As this is 50, this must be equal to 450, and if this is 500, okay, we have to calculate these two values now. This is 600, this is 50, so this value must be 600 minus 50, that is 550, alright. And now we have to calculate this value. As this is 450, this is 400, so total must be equal to 400. Again, this is 500, this value is 550, so this value must be equal to minus 50, right? So as we have one of the value negative, one of the class frequency is negative, one of the class frequency is negative, and therefore the data are inconsistent, and this is not suitable for further mathematical calculations. So this is how we check the consistency of the data. So we have one more example, so you can solve it and find out whether the data are consistent or not. So I leave it to you as a homework or practice. Independence of attribute. So if the attributes are said to be independent, the presence or absence of one attribute does not affect the presence or absence of other attribute. So this is what independence of attribute. Basically we are studying association of attribute, but for association of attribute we need to study the independence of attributes also. So if the attributes are said to be independent, it means that the presence or absence of any attribute does not affect the presence or absence of any other attribute. For example, the attribute skin color and intelligence of the person are independent. So if two attributes A and B are independent, then the actual frequency is equal to the expected frequency. So this is something is very important. If there is no association between the attribute and the attributes are independent, then in that case the actual frequency, how do we calculate? This is the actual frequency which we get from this particular table, and this must be equal to the expected frequency. Also on the left hand side we have actual frequency, so from table we can judge it. This is actual frequency, and this actual frequency must be equal to what? Expected frequency. Expected frequency is given by this. So this is actual frequency of that particular class. This is expected frequency. So when actual frequency is equal to expected frequency, we say that the attributes A and B are independent. We have one more example here. On the left hand side we have alpha beta, that is absence of both the attribute, and this is the actual frequency, and we can calculate the expected frequency also by this particular value, and we can judge if the attributes are independent or not. Association of attributes. Two attributes A and B are said to be associated if they are not independent. So it is quite obvious. If they are not independent, they are associated. So two attributes A and B are said to be associated if they are not independent, but they are related with each other in some way or the other way. The attributes A and B are said to be positively associated if now this is on the left hand side we have the class frequency, as we have seen here the actual frequency, and on the right hand side we have expected frequency. So if the actual frequency is greater than the expected frequency, the attributes A and B are said to be positively associated, and if the actual frequency is less than the expected frequency, the attributes are called as negatively associated. Now this is something very important to understand. If the attributes, if the actual frequency is greater than the expected frequency, now we know how to calculate the expected frequency, and actual frequencies are given, or we have to complete that particular table. So if the actual frequency is greater than the expected frequency of those attributes, then the attributes are said to be positively associated, and if the actual frequency is less than the expected frequency, then the attributes under consideration are called as negatively associated. So we have an example here. Show that whether A and B are independent, positively associated or negatively associated. So we have some values here. Let me take the pen again. So we have AB 128, alpha B is 384, then A beta is 24, alpha beta is 72. So we can calculate various values here by putting all these values in the table, this particular table. So by putting all these values in this particular table, we can calculate the rest of the values. So the value of A comes to be 150, the value of B comes to be 512, the value of alpha comes to be 456, and so on. Now what we have to do, we have to check the attributes A and B, whether they are associated, positively associated, negatively associated or independent. So what we have to do, we have to compare the actual frequency with the expected frequency. Now the actual frequency is AB, here it is calculated or given 128, it is given 128. So on left hand side we have this actual frequency. Now let us calculate the expected frequency. Now the expected frequency of AB is equal to what? A multiplied by B divided by N. Now A is equal to 158, 152, B is equal to 512, and N is equal to 600. Okay, this is multiplication, 608. So once we can do it, once we calculate this, we find that okay, 15 fours are 608. So 15 fours are 600, 154s are 608, and therefore 152 fours are 608. Okay, and this must be equal to 512 divided by 4 must be equal to 256 divided by 2 is 128. So this value is 128, and therefore the expected frequency is equal to actual frequency, and we can say that the attributes A and B are independent, as the actual frequency is equal to expected frequency in this particular case. So there is no association. If they are independent, there is no association, nor positive, neither positive nor negative. Then there is something which is called as Yule's coefficient, which gives us a coefficient, means the value between -1 to +1. From that we can judge whether the attributes are positively associated or negatively associated, whether they are associated or not, and what is the strength of their association. So the above example gives us an idea about association, but not the degree of association. So this particular coefficient gives us the importance of, gives us the value of or the degree of association between the two variables. And for this, Professor G. Udny Yule has suggested a formula to measure the degree of association, and it is a relative measure of association between the two attributes A and B. If AB, alpha B, A beta, alpha beta are the four distinct combinations of A, B, alpha, beta, then Yule's coefficient is given by this particular formula, and it is denoted by Q. So AB multiplied by alpha beta minus A beta multiplied by alpha B divided by AB, then alpha beta plus A beta alpha B. So this is how it is done. So let me draw the table once again for you. Okay, so A is the presence of attribute A, alpha is the absence of attribute A, B is the presence of attribute B, beta is the absence of attribute B. So what do we write here? We write here class frequency AB, then this will be alpha B, then we write here A beta, then here we write alpha beta, then what do we write here? This is equal to B, this is beta, this is A, this is alpha, and this is the total addition, right? This was our table, if you can remember, A, alpha, B, beta, yes, and this is N. Now these are also frequencies, these are also frequencies. So how do we calculate it? AB multiplied by alpha beta, so this diagonal multiplication, right, this diagonal multiplication, then minus, so this diagonal multiplication minus this diagonal multiplication, and divided by this diagonal multiplication plus this diagonal multiplication. So this is how we have to do. So AB multiplied by alpha beta minus A beta multiplied by alpha B divided by AB multiplied by alpha beta plus A beta multiplied by alpha B. So this is how we calculate Yule's coefficient Q. If the value of Yule's coefficient is +1, we say that there is a perfect positive association. If the value of Q is -1, we say that there is a perfect negative association between the variables. And if the value of Yule's coefficient Q is equal to 0, we say that there is no association and A and B are independent. So investigate the association between the darkness of the eye. So we have an example here. So investigate the association between the darkness of the eye color in father and son from the data. So we have some data here on the basis of which we have to calculate Yule's coefficient, and we have to judge whether there is any association between the darkness color of eye in father and son. So fathers with dark eyes and sons with dark eyes is 50. So we have to form this particular table before we calculate Yule's coefficient. Let me take a pen again. So fathers with dark eyes and sons with dark eyes. So this is the presence of this attribute dark eyes. So this is presence of dark eye in father. This is presence of dark eye in son. So this is son, we will call it son, and this is father. So presence of dark eye in father, and as well as presence of dark eyes in case of son. So this must be equal to AB. So this frequency is 50. Then fathers with dark eyes, sons with no dark eyes. So fathers with A and sons with beta. So this is 79. Then fathers with no dark eyes and sons with dark eyes. So fathers with alpha and sons with dark eyes. So alpha B, this is equal to 89. And neither son nor father having dark eyes, this is equal to 782. So this is alpha beta, that is absence of dark eyes in both father as well as son. So this is 782. So we have all the data to calculate the Yule's coefficient. How do we calculate? Q is equal to I think without writing the formula itself we can calculate it. So 50 multiplied by 782. So 50 multiplied by 782 minus 79 multiplied by 89. This is divided by 50 multiplied by 782 plus 79 multiplied by 89. So this is how we calculate the Yule's coefficient. This must have been calculated on the next slide. Okay, we have a table here, so we can put all these values in this particular table. Already we have formed a table and we have put the values, and this is how we do it. So when we calculate this, we get this particular value. So the answer is 0.69. So this value you can calculate it. This is equal to 0.69. So the Yule's coefficient is found to be 0.69. So we can say that there is a positive correlation, or positive association between the darkness of eye color in father as well as in son. So this is how we can interpret, or we can find out the Yule's coefficient. So thank you for watching this particular video. Keep watching rest of the videos. Thank you all.